This is section 1.3.1, problem solving. In this section, we're going to cover the 4 steps of problem solving. You've probably seen these steps before. In fact, past teachers have probably preached to you about applying them. Let's review them. Step 1, understand the problem. Not only does this mean you need to read the problem, but you need to comprehend it. You need to know what the problem is telling you. Decide what information is important and identify what is the question. Step 2, devise a plan. Think. Take your time. Use reason, logic, and your knowledge of math. Step 3, carry out the plan and solve the problem. This is where you will apply your math skills. And finally, step 4, look back and check the answer. Remember, applying good estimation techniques will tell you whether or not you have an appropriate answer. In example 1, we need to find out what information is missing. A man purchased 5 shirts, each at the same discount price. How much did he pay for them? Of course, they didn't tell us what the discounted price is, so we cannot decide how much he paid for the shirts. In example 2, we need to find out what information is unnecessary. A roll of Easy White paper towels contains 100 sheets and costs $1.38. A comparable brand, Quick Clean, contains 5 dozen sheets per roll and costs $1.23. If you need 3 rolls of paper towels, which brand is the better value? Now this problem gives us quite a bit of information. It tells us how many sheets per roll for each brand, as well as the cost. But if you identified the part in the problem where it says you need 3 rolls of paper towels as unnecessary information, you're correct. Of course, the brand that ends up being the better value would be a better value for 1 roll of paper towels, or 2 rolls, or 3 rolls, or however many rolls you needed to buy. Knowing that you need 3 rolls of paper towels is unnecessary information. Example 3. Now we're going to apply the 4-step procedure. Let's start by reading the problem carefully. By paying $100 cash up front and the balance at $20 a week, how long will it take to pay for a bicycle costing $680? Okay, so we're purchasing a bicycle. We're going to pay $100 up front. So if the bike costs $680, but we're paying $100 up front, that means we have $580 to pay off. And we're going to do that by paying $20 a week. So now we can come up with a plan. It seems to be that if we have a balance of $580 and we're going to pay it off in $20 increments, we need to find out how many times 20 goes into 580. So of course, what this means is we need to do some division. We need to take $580 divided by 20. This will give us how many weeks it'll take to pay off the bike. When we divide each of these by 10, we know we can cancel these zeros out. And 58 divided by 2 is 29. So we know that it'll take 29 weeks to pay off the bicycle. Now the final step in the problem-solving process is to check your work. Let's double check here. 29 weeks at $20 per week. Is $580. And of course, we paid $100 cash up front, so if we add on the 100, that gets us back to $680, which was the original cost of the bicycle. So we can be sure that 29 weeks is the correct amount of time to pay off our bicycle. In our next example, we're going to solve a problem by making a list. This is certainly a reasonable method for problem solving. Suppose you are an engineer programming the automatic gate at a parking garage for a 50-cent toll. The gate should accept exact change only. It should not accept pennies. How many coin combinations must you program the gate to accept? Well, we're going to solve this problem by making a list. We're going to list out every possible coin combination we can think of for 50 cents, but not including pennies. Now, making a list is a great way to solve a problem. However, you need to do it in an organized manner so you don't miss any possible solutions. So, first thing I think we should do is think of the different coins that could go into this parking garage gate. So we know that pennies aren't included, but that leaves us with nickels, dimes, quarters, and don't forget half dollars. Now we need to come up with the different combinations that give us 50 cents. Well, of course, if we use a half dollar, we only need one half dollar, and we don't need any other nickels, dimes, or quarters. If we use quarters, we can use 2 quarters, no half dollars, no dimes, no nickels. But what if we use only 1 quarter? Now if we use 1 quarter, we still have 25 cents left. So we could use 2 dimes and 1 nickel with that 1 quarter. Or with 1 quarter, we could use 1 dime and 3 nickels. Or with 1 quarter, we could use 5 nickels. Are there any other options that would include using 1 quarter? I think we've covered them all. So let's go on to if we're using dimes. So if we're using dimes, we could use 5 dimes. If we use 5 dimes, we don't need any nickels, and we don't need any quarters, and of course no half dollars. What if we use 4 dimes? That's 40 cents. Well, we could use 2 nickels with that to get us to 50 cents. 3 dimes would be 30 cents. We need 20 more cents, so that would be 4 nickels. We've already covered using 2 dimes in this option right here, so we don't need to do that again, and we've already covered using 1 dime right there. Now let's take a look at using our nickels. We've already covered the options for using 1 nickel, 2, 3, 4, and 5 nickels. Well, to get 50 cents, we could use 6 nickels. 6 nickels would get us to 30 cents, and then we would need 2 dimes. So 6 nickels and 2 dimes. Let me go back to using my blue. 6 nickels would give us 30 cents, and 2 dimes would give us 50 cents. How about 7 nickels? 7 nickels would give us 35 cents, but then we can't get to 50 cents by using dimes or quarters or half dollars. So I don't think using 7 nickels is going to help us. Let's extend the page here a little bit. So how about 8 nickels? 8 nickels would give us 40 cents. We need 10 more cents, so we could use 1 dime. No quarters, no half dollars there. 9 nickels would get us to 45 cents, but then we couldn't get to 50 cents with any dimes, quarters, or half dollars. So I think the next option would be 10 nickels, in which case we have our 50 cents and we don't need any dimes, quarters, or half dollars. Now let's think for a minute about any other possible options of 50 cents. By taking a minute to think through this, I think we've covered all possible coin combinations. So now we can count up the number of combinations, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different ways to program the coin collector at the parking gate. All right, finally, solving a problem by using a diagram. 4 runners are in a 1-mile race: Maria, Aretha, Thelma, and Debbie. Points are awarded only to the women finishing first or second. The first place winner gets more points than the second place winner. How many different arrangements of first and second place winners are possible? After reading and understanding the problem, it seems like a good plan would be to start with one individual winner. For example, let's say that Maria wins. So if Maria is our winner, there are a few different ways that Maria can be our winner. One way would be that if Maria wins, and then Aretha wins, and then Aretha comes in second, Thelma third, and Debbie fourth. Or maybe Maria wins and Aretha, let's see, first place winner gets more points than the second place winner. How many different arrangements of first and second place winners are possible? So let's think about this. So now that I read the problem more carefully, since they're asking how many different arrangements of first and second place winners are possible, we probably don't need to worry about third and fourth place. So our first option here is if Maria comes in first and Aretha comes in second. Then we could have if Maria comes in first and Thelma comes in second, or if Maria comes in first and Debbie comes in second. So it seems like there are 3 different ways that Maria can come in first. Now we can think about if Aretha comes in first. So if Aretha comes in first, maybe Maria comes in second, or Thelma comes in second, or Debbie comes in second. So there are 3 ways that Aretha can come in first. Then, if Thelma comes in first, there's going to be 3 ways for her to do that, because Maria could be second, Aretha could be second, or Debbie could be second. And finally, if Debbie comes in first, Maria could be second, Aretha could be second, or Thelma could be second. So it seems like there are 3 different ways that each girl can come in first place. So these are the different combinations for first and second place. So when we total them up, we have 12 different ways that first and second place winners are possible. So we've reviewed the 4 steps of problem solving: understand the problem, devise a plan, carry out the plan and solve the problem, and look back and check the answer. We also went over a couple different ways to problem solve by creating lists or making diagrams. This has been section 1.3.1 on problem solving.